Okay, pre-cal, in this video we are continuing Unit 7, Topic 2. So we are looking at more trigonometric identity proofs here. So I'm going to start with number 5. And there's a couple of different ways to do this problem. So I'm just going to start with the first one that may or may not be obvious to some of you. We have this term, and then we have subtraction, and then this term right here. And remember, our goal is to make it look like sine squared theta. So if you'll notice, each of these terms that are being subtracted both have a cosine squared theta. So I'm just going to factor the cosine squared theta out from each of the terms. And of course, that is just factoring. And then what I'm going to do is I'm going to visit my identities page. And if you'll notice on your Pythagorean identities, we have secant squared theta minus 1 equals tangent squared theta. So I am going to change that. So I've got cosine squared theta times tangent squared theta, if I could spell tangent. And of course, that is the Pythagorean theorem identity that I used right there. And of course, what you can do is you can expand this so that you can see it easier. Sometimes it's easier to see what you're doing when you expand things. And then what you can do is you can change tangent because we need sine in our problem, and the easiest way to do that is, of course, to use our quotient identity because tangent can be written as sine over cosine. So that is going to help us. So I am going to write cosine cosine, and I'm going to replace tangent with sine theta over cosine theta. I'm going to do that twice because there are two of them. And that, of course, is just your reciprocal identity. Or no, that was the quotient identity. Shame on me. I'm out of control. All right, so then all we have to do is remember that these are over 1, and then we can just reduce right here and multiply sine theta times sine theta. So I just reduced and multiplied. And of course, you don't necessarily have to use that expand step. I just thought it would be easier for you to see what was going on. Okay, so now I'm going to do it in another way. So let me switch my pen color up here, and I'm just going to write it to the right over here. What I could have done, I could have replaced secant squared theta with 1 over cosine squared theta using my reciprocal identity. So I could have done it that way. Okay, and this of course would have been my reciprocal identity. So, because remember from my identities handout, I know that secant is equal to 1 over cosine, so secant squared would be equal to 1 over cosine squared. All right, so then once I do that, I can then reduce, and I'm left with 1 minus cosine squared theta. And of course, when I revisit my identities page again, I know that 1 minus cosine squared theta is equal to sine squared theta. So that would be sine squared theta. And this, of course, is going to be the Pythagorean theorem identity. So that one's a lot shorter if you want to do it that way. So that might be helpful. Okay, so now I'm going to erase that. So make sure you pause this and look at it again. All right, so now I am going to visit number 6. So when we look at number 6, the first thing I notice is that I have a fraction, and there's nothing being added or subtracted to the fraction. So that means I'm going to have to split it up because sometimes it's easier to look at this way. So I am going to rewrite it like old school division, like little kid school. All right. So when I rewrite it that way, the very first thing I'm going to do is I'm going to go ahead and expand this. Again, you don't have to expand it. I just think sometimes it's easier to see this way because of how your identities page looks. Okay, so notice that my goal here is to make this look like this. I want it to read as cosine squared theta. So I need to get cosine into my problem. So I'm going to visit my identity sheet and see what can help me here. So the first thing you should recognize is that I can rewrite cotangent using my quotient identity as cosine over sine. So that's going to be really helpful. And then I'm going to go ahead and address the fact that we have cosecant in our problem and remind you that cosecant can be written as 1 over sine. So when I revisit my notes, what I'm going to do is change this to cosine theta over sine theta. Going to change both of these, and I'm also going to change this. Okay, so what have I done here? Well, this is just a rewrite, but it means the same thing. I'm still using division, so I'm not going to change that. I did expand this right here. And then now I'm using a quotient identity, and I use the reciprocal identity. So I'm going to account for both of those. Okay, so now what I can do, cosine theta over sine theta times sine theta, oops, I don't know why I did that, times cosine theta over sine theta. Remember, this can be written this way, divided. When you're dividing by this, you can actually multiply by the reciprocal. And then, of course, I'm just going to reduce, and I end up with exactly what I need. So I just reduced. There you go. Easy peasy, lemon squeezy.